Hi, John at Byte Basics here. This is a worksheet video. I'm just going to be working through some of the problems from the Introduction to Number Systems worksheet. If you haven't seen the Introduction to Number Systems video or tried the worksheet, it may be better to do that first. So jumping into question 1. For this question, you just need to name 3 number systems and their bases. So in the video, I mentioned decimal, which is a base 10 number system, binary, which is a base 2 number system, and hexadecimal, which is a base 16 number system. However, if you can't remember one or two of them, you could have actually looked down to question 3, and you'll see I named 2 more. So there's ternary here, which is base 3, and octal, which is base 8. On to question 2. For this question, you need to tick whether the given number is a valid binary, decimal, or hexadecimal number. To answer this question, you first need to know what the valid digits are that are allowed if the number is split into columns. So for binary, those digits are 0 and 1. For decimal, those digits are 0 to 9. And for hexadecimal, those numbers are 0 to 9 and the letters A through to F. Once you know that, we just need to think of the numbers split into columns and then compare the digits. So for 0, well, that's valid as we're allowed 0 and 1 in binary, it's valid as we're allowed 0 to 9 in decimal, and it's valid as we're allowed 0 to 9 in hexadecimal. Again, the same with 1, it's valid for all of them. Now when we get to 52, if we split that into columns, we have a 5 and a 2. And in binary, we're only allowed 0 or 1. So no, it's not valid for binary, but it is of course valid for decimal and hexadecimal. 1 0 1 1 0 1 0 1. If we split it into columns, it's all 0 and 1s, so it's fine for binary, decimal, hexadecimal. A5E 243. Well, if we split this one into columns, we have an A, and we know that isn't valid for binary, and it's definitely not valid for decimal. But we can see with hexadecimal, we're allowed A to F. And both A and E are in A to F, so it is a valid hexadecimal number. 7934 is valid for decimal, valid for hexadecimal. 01, that's valid for binary, decimal, and hexadecimal. You can just ignore the 0 at the beginning. It would be like if you had decimal number 34 and just added a 0 at the beginning. It doesn't actually make any difference. The letter E is obviously not valid for binary, decimal, but is valid for hexadecimal as it's in A to F. H3A43, we have an H here, and H isn't in A to F, so it's not valid for any of them. And finally, 96235452242 is valid for decimal and hexadecimal. What you may notice here is if it's a valid binary number, it will also be a valid decimal and hexadecimal number. If it's a valid decimal number, it will be a valid hexadecimal number. So you can do a bit of a sanity check, and you can look through, make sure any row where you have binary checked also has decimal and hexadecimal ticked in that column as well. For question 3, you need to remember the 2 rules from this part of the video. So for the single digits, we can have from 0 to the base minus 1. So for ternary, that's 0 to 3 minus 1, which would be 2. And for octal, that's from 0 to 8 minus 1, which would be 7. So that's the first part of the question done. Then the second part, we can see the column values are increasing powers of the base, starting with to the power 0. So for ternary, that would be 3 to the power 0, 3 to the power 1, 3 to the power 2, 3 to the power 3, 3 to the power 4. And then if we go through 3 to the 0, well, anything to the 0 is 1. 3 to the 1, anything to the power 1 is the number itself, so that would be 3. 3 to the 2 is 9. 3 to the 3 is 27. And 3 to the 4 is 81. We do exactly the same with octal. So this time the base is 8, so we start base to the power 0, then increasing powers, so 8 to the 1, 8 to the 2, 8 to the 3, and 8 to the 4. And 8 to the 0 will just be 1, because again anything to the power 0 is just 1. 8 to the 1 is just 8, because anything to the power 1 is just that number. 8 to the power 2 is 64. 8 to the power 3 is 512. And 8 to the power 4 is 4096. And that's question 3 complete. On to question 4, which is the optional programming question. I'm not going to cover that as it's an optional question, but I'll leave a link to my solution in the description. If you have any questions or feedback, please leave a comment. This was my first worked examples video, so hopefully I'll be able to improve them in the future. As always, thanks for watching and hope to see you in the next video.